Let's do a couple examples involving function composition. I'm given two functions, f of x equals 1 over x minus 2, and g of x equals the square root of x minus 3. I'm asked to find the function f composed with g in its domain, and then f composed with f in its domain. But before we get started with these two problems, let's just talk about function composition for a moment. When I write f composed with g of x, what I really mean is f of g of x. So when I'm plugging in an x value, I first plug it into g of x, and I get a number. And then I take that new number and I plug it into f, and I evaluate that to a final answer. So it's a two-step process, and whenever I'm thinking about function composition, even if I've written a formula like I'm being asked for in number 1, it has to be able to go through this two-step process. So let's evaluate f composed with g of 4 using this two-step process. If I look at just the inside function, I'm going to start by evaluating g of 4. 4 minus 3 is 1, the square root of which is also 1. So g of 4 is 1. So I've done the first part. And now I have to evaluate f of 1. 1 minus 2 is minus 1. 1 over minus 1 is minus 1. And there I have it. That's f composed with g of 4. Whenever I'm thinking about function composition, and especially when I think about the domain, I remember that everything has to be able to start on the inside function, which really means whatever x value I'm playing with has to start in the domain of g. That's not going to be my only concern, but it's my first concern, that whatever x value has to be able to go through the inside function first. So now let's try to answer number 1 here, finding f composed with g and its domain. So I'm not worried this time about a specific value of x, but a general value of x. Okay, well, if I think about the outside function, the outside is always 1 over something that's getting plugged in for x minus 2. And in this example, the something getting plugged in to the function is g of x. So that's the square root of x minus 3. So there's a function, there's a formula for f composed with g of x. I'm going to rewrite it down here without those parentheses, although it's fine written like that and it's fine written like this, but this is what I'd like to think of as a shortcut formula for f composed with g of x. A moment ago we found f of g of 4 by first plugging 4 into g, getting the number 1, and then plugging that into f. Now I could just in one step use this formula. Four minus 3 is 1. The square root of 1 is 1. 1 minus 2 is minus 1, and we still get the same value, minus 1. So whether I use this one-step formula or this two-step method, I get the same thing. And now we have to think about the domain of f composed with g. And I like to think about this finding a domain in just a few easy steps. First, I'm going to write down the domain of g. Because whatever the domain of f composed with g is, it can't be any bigger than the domain of g of x. All the x values have to be able to be plugged into this function to get started. The next thing I'm going to do is I'm going to remove any values from the domain of g that don't work in my new formula. Your author has a statement kind of like this in the textbook. It's not written exactly the same way, but this is the way I like to think about this process. It's always a two-step process. First, writing down the things that are allowed to go into the function g, and then removing anything that doesn't work when I've built the function f composed with g. I think about it like filtering. It's a two-step filtration process. First, my x values have to be able to go through the domain of g, and then the ones that are left after I just write down the domain of g still have to work in this new formula. So, I'm going to write down the domain of g, and I'm going to use a big D and a subscript g, just so whoever reads this knows that I'm not talking about any domain, I'm talking about the domain of g. And the domain of that square root function is from 3 to infinity, right? Because underneath the radical, I can think about the x minus 3 part having to be bigger than or equal to 0 to be able to evaluate that square root. So x must be bigger than or equal to 3, which is the interval from 3 to infinity. So my first step is done. All of the x's I ever get to use start in that interval. And now I need to remove from that any values that fail to work in this new formula. And then I'll have the domain that I'm looking for, the domain of f composed with g. Well, if I look at the function I've written down, all I'm worried about now is that the bottom might equal 0. So I'm going to find any x's where the bottom of this fraction are equal to 0, and I'm going to throw them out of the domain. I end up with the square root of x minus 3 equals 2. I'm going to square both sides, so x minus 3 is equal to 4. Adding 3 to both sides, I get x is 7. If I plugged a 7 in for x, I would get 0 on the bottom of that fraction, so I have to throw 7 out of my domain. So I'm left with 3. I have to throw out 7, so that breaks this interval into two different ones. And there's my domain for f composed with g. I'm allowed to plug in any value starting at 3, going to but not including 7, and then any value bigger than 7. That's my domain for f composed with g. Going back to our original set of questions, now we're asked to find the domain of, we're asked to find the function f composed with f and its domain. So let's get a fresh board and see if we can do that. So we're looking for f composed with f and its domain. F was the function 1 over x minus 2. Let's find the function f composed with f. And then we'll write down its domain. All right, so the outside function f is 1 over something minus 2, and that something this time is the function f itself, 1 over x minus 2. That gives me a compound fraction. So I'm going to do a pretty common fraction trick to get rid of the compound fraction to make this formula a little easier to use. I'm going to multiply the top and bottom by x minus 2, the least common denominator I see in all of the places. Since it's the only denominator other than 1, right, I can really think of this as 1 over 1 and 2 over 1, it was pretty easy to spot. And so now my job on the bottom here is to distribute. And on the top, 1 times x minus 2 is just x minus 2. Distributing the x minus 2 over here gives me 1, because the x minus 2's cancel, minus 2 times x minus 2. And now I can simplify this part. One minus 2x plus 4. So my final answer for f composed with f of x, I have x minus 2 on the top, and then 5 minus 2x on the bottom. 4 and 1 make 5, and I still have that minus 2x. So, my original function f was 1 over x minus 2. And through all of that, now I know f composed with f of x is x minus 2 over 5 minus 2x. So if I go through my two-step process this time, the first step last time was to write down the domain of g, but that was because g was the inside function. The real idea here is I start by writing down the domain of the inside function. Well, my inside function this time is f. So I write down the domain of f, and the only thing x can't be here is 2, because I can't divide by 0. So the domain of my inside function includes all of the real numbers except for 2. Now what I need to do is look for any values of x here that don't work in this new formula. And again, the only thing I'm worried about is dividing by 0. If this had a root in it, I might be worried about, if this had an even root in it, I might be worried about negative values under that root, but this problem I'm worried about dividing by 0. Add the 2x to both sides, divide both sides by 2, and I find out that if I had x equal to 5 over 2, I'd be dividing by 0. So I have to leave out 2, and I have to leave out 2.5. So my final answer for the domain of f composed with f is the interval from minus infinity to 2, leaving out 2, and then I have an interval from 2 to 5 over 2, 2.5, leaving out the 2.5, union 5 over 2 to infinity. Sometimes it's nice to think about things like this on a number line. I have two values I have to leave out. If I was drawing this on a number line, I'd think about leaving those out by drawing an open circle around them and then shading everything else. And so what I've shaded here corresponds to these three intervals. Everything that's less than 2, the things between 2 and 2.5, and the things bigger than 2.5. And there we have two examples of finding a function, finding the composition of two functions and that new function's domain.